All right, hey, we're going to talk about fraction and decimal equivalents. I really hope everybody had a good spring break. Let's get back to it and try to get this stuff done. All right, here. Um, Notice that our little number line here on our title thing, I have put up this graphic of where the decimal point right here, what the heck was that, would go right here. This is our decimal point. Notice that to the left, this side of the decimal point, it starts off with ones, tens, goes to hundreds, thousands, so on. But notice if I go to the right, the less than one whole side, I don't have a ones place. I only have a tenths. That's where I start. That's my lowest on the decimal point whatever side. And as my little note down here says, notice that the decimal numbers have the suffix th. All of them do. Tenths, hundredths, millionths. So that's one way to know that we can talk about whether or not we're talking about the more than or less than one whole. Okay, we're going to move on to the lesson now. Oh, I'm sorry, I forgot Common Core standards. Understand decimal notation for fractions and compare decimal fractions because a decimal is a type of fraction, such as 6.62 is the same as 62/100ths. You have to be able to recognize that. You have to be able to rewrite them either way. Describe a length as 0.62 meters and locate 0.62 on a number line. So where is 0.62? Well, we're going to figure out how to do that. All right. So here we have a number line, and it's only as 20, 21, 22. And this is something I was going to have you do in class, but if we can't, we may not get to it, so I just wanted to do it here for you. And I've added a couple lines in the middle because I wanted to have it kind of with, so we could do it in tenths. So if I, on here, where would 20 and 1/2 be? 20 and 1/2. Well, it would be between 20 and 21. So I have, how many lines? I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have 10 spaces in here. So my 1/2 would be, see, right about here would be 20 and 1/2, right? Now I'm doing this at home, so my writing is going to be a little bit off if I when I try to do it. I'm going to try to type it and see if I can do it that way. It doesn't look like it's going to look really particularly good, but all right. Now I've got lines down there. All right, anyway, 20 and 1/2. All right, there's my 20 and 1/2. Okay, so I have 1, 2, 3, 4. 1, 2, 3, 4. So that must be right in the middle, right? 20 and 1/2. Now, what would be the tenths in between here? So I have, if each one of these is a tenth, this is 1/10, 2/10, 3/10, 4/10. What would this one here be? So this would be, I'm just going to try to write it with a pen here. This would be 1/10, 2/10, 3/10, 4/10. So what would this one be then? If I took that 20 off of there, and what would this would be? This would be 5/10, right? So what does that tell us? What is 5/10 equal to? Well, it's equal to 1/2. And I know that if I make an equivalent fraction and I divide both of these by 5, I'm going to end up with 5 divided by 5 is 1. 10 divided by 5 is 2. 1/2. So 5/10 is the same and is equivalent to 1/2, right? So, and that's all we're talking about doing here. Okay, 5/10 is what is the equivalent to? So what is that equivalent to in a decimal? Well, how many places over is a tenth? Well, it's my first place here, correct? So 5/10 would be 0.5, just like that. So this decimal is equivalent to both of these fractions. Okay? Now, there is, one way of looking at this is whenever I make this fraction into a number over 10 or over 100 or over 1,000, whatever, however many zeros there are, that's how many places to the left you go to put your decimal. Like if I had this as 5 and I knew it had to be a decimal, I know that this has 1 0, so I move it one place to the left. Now I have 0.5. It's the same thing, okay? Okay, so let's mark our tenths between 21 and 22. So this would be 21 and 1/10, 21 and 2/10, 3/10, 4/10, 5/10. Well, I'm getting bigger as I go. 6/10, 7/10, 8/10. Whoa, that was sloppy. And 9/10. Okay. All right. So there we are again. Same kind of thing as we were doing before. Now, where would I mark if I wanted to get 21.25? If I wanted to mark, and I'll put it in red, if I wanted to mark 20, oh my goodness gracious. What did I just do there? I don't even know what I did. Let's do that again. 21.25 is what I'm going to be looking for. Where would I mark that at? And 21.25. Where is that on this number line? Well, it's not, well, we have, if this is 2/10, this is equivalent to 21.2, right? And this is 21.3. So this has to be right in here somewhere, right? In between these two somewhere. Because it's 0.25, so it has to be in between there. It's about halfway in between those two places. Okay? Yeah, that's because remember I've told you before that in between this right here, I can divide this up infinitely small, and I can just keep going forever. So 21, this is going to be 21.2. This is equivalent. These two are equivalent right here. And so there's going to be like 0.21, 0.22, 0.23, 24, 25, 26, 27, 28, 29, and then we get to 0.3, like this is a 30, 30. I could put a 0 on the back of here and it'd be the same thing. Okay? So in between here is 21 through 29, and then here's 30. Okay, so right in between would be 2.5. All right? If you have any questions, remember, write them down so we can talk about them in class, and I can go over this with you more there, okay? You know, and you'd be doing the same thing, you know, ask mark 21 and a quarter, 21 and 2/4. Well, we already marked 21 and a quarter, right? That's this. This is a quarter right here, right? 21 and 2/4, 21 and 3/4, all of those. And what decimal would you put if I asked you to mark 21 and 3/4? What would be the equivalent decimal for that? 3/4. Think of money. Think of 100. 3/4. What would that be? Well, 3/4 is going to be. Well, no, 3/4 isn't. 3/4 is going to be almost all the way to 22, right? Because 3 out of 4 pieces is almost the whole piece of pizza. So it's going to be almost all the way over here, and it's going to be 21 point. What's 3/4 of a dollar? You have a quarter, you have 50 cents. What comes next? 75. 21.75 would be the next thing. So that would be right about here, right? Right in the middle between 21 and 7/10 and 8/10. 0.75, right? Okay, so hopefully that helps you a little bit. We're going to talk about them a little bit more. I'm going to move on and try to figure some more of this out. Okay, so here we have two models here. Notice that how many spaces, how many white spaces are there in between these black bars? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this has 100, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 times 10 is 100. So, is the same amount colored in on both? Yes, they're both percentage-wise the same. 50% is colored in here and is colored in here. So this is 0.5, which equals, in this case, 5/10. If I divide both of these by 5, what do I come up with? 1/2. Now, same thing over here. This is, while not just 0.5, this is because I've multiplied this by 10. So this is 0.50 because this is out of 100, right? But that still equals 50 over 100. And if I divide both of those by 50, I still end up with 1/2, right? So I divide both of these by 50. 100 divided by 50 is 2. 50 divided by 50 is 1. 1/2. Same thing as over here. It's just I've made an equivalent fraction. I made this. This is 10 times bigger than this. So these answers are 10 times bigger than these. Okay? But they're the same amount. They both come out to half of the whole. All right? Again, please remember any of your questions and these two number lines show you how these numbers are equivalent. See, 2/10, like we had marked on our 20 to 22 number line, 2/10 is the same as 0.2. This is in the 10th place. 1, 0, it comes over from here. I move it over to here. I have 2/10, right? 3/10, 0.3. Whenever I talk about tenths, it's that number right to the right of the decimal. 5/10 is the same as 0.5, which would also be the same as 1/2. Okay, so you can see how these are equivalent. All right. Now there's a mistake right here, obviously, where the people who made this they repeated 0.7 instead of putting 0.8 right here, which is what they should have done. Okay. All right, now it's really helpful when you're finding the decimal equivalent of a fraction to have the denominator or the number on the bottom, we talked about that, equal 10 or 100, or any one with zeros, 1,000, a million. It makes it easier. It's not necessary to, if you can't, if it has to go up to those really high numbers, it makes it a little bit more difficult, but it's still easier than if you don't do that. Okay, and sometimes you just got to get as close as you can to 100 or 10, and we can talk about that later. So if I have the number 3/4 like I have right here, what number can I multiply the denominator, this number right here, this denominator, by to get either 10 or 100? Well, I can get kind of close to 10 if I multiply this by 2, but it's not it's not 10. Now I can get to it specifically exactly 100 if I multiply this number by another number. What can I multiply it by? And remember, I have to keep it equivalent, so I have to multiply both the denominator and the numerator by that same number. But this is going to decide what I multiply by, because it's going to get me to 100. So I can multiply that by 25. So I have to multiply this by 25. So what is 4 times 25? Well, I've already said it, that it's 100. Okay, so what's 3 times 25? Well, it's going to be 25 less than 4 times 25. So what's 100 minus 25, or 3 times 25 is 75. So what decimal is equivalent to 75 hundredths? Well, remember, if I have the number 75, like this right here, normally have a decimal right here, correct? But since this one, it's over 100, this hundredth right here has 2 decimals, I move this 1, 2, I'm sorry, not 2 decimals, 2 zeros. I move the decimal over to the left 2 places, once for each 0, 1, 2. So now I end up with 0.75. Okay? So 0.75 is what's equal to 75 100ths. Is that clear? And if it's not, please ask your questions tomorrow. And oh, let me just show you that I have. Whoop, there it is, 0.75. All right, let me move these back down so I don't forget. There it is. I'll erase this so I can torment people in class tomorrow with it. All right. So moving on to the next one. All right. So these are common fraction decimal equivalents. Notice this one and this one are exactly the same. 1/2, 2/4 are the same thing. They equal the same. Okay. This has, let's go with this. This has been multiplied by 2. 2 times 2. 2 times 1 is 2. 2 times 2 is 4. They both equal 0.5. 1/5. Notice that it's equal to 0.2. Now, look at the denominators and see what number was used to get either 10 or 100 in the denominator of each fraction. Is that the same number multiplied by the numerator to get the equivalent decimal? So what did I multiply by to get this number 5, either to 10 or 100? Well, I multiplied by 2. So what I end up with is 2 over 10, because 2 times 5 is 10, 2 times 1 is 2, so 2 over 10, that gives me 2/10. Okay? Now, what did I multiply? And I just did this one before. I multiply this by 25, so I have to multiply this by 25. 3 times 25 is 75, and notice that's what I get for to the right of my decimal. It's going to be the same thing here. I'm going to multiply this by 2 to get to 10, and then I'm going to multiply this by 2, this numerator by 2, and that's going to give me 8 over 10, 8 tenths. Same thing. Okay? Hopefully this is clearing it up for you. If it's not, I really want you to ask me questions. All right, there are some examples. Now I'm not going to talk, I'm going to stop this for a second. And well, you're going to stop it because you're watching this, you may be watching this at home. So stop it, try to figure these out, and if you can, then, you know, that means we're effective. We're doing good work here, and we can talk about it more in class. Okay? So turn it off. Well, stop it. Pause it. Okay, I'm going to assume that you paused it and you gave it a shot, and that, you know, everything you did what you were, you know, you tried to think about it. All right, so here we have we're looking at the spaces in between the bars. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, I already counted that I have 5 green and 5 not shaded. So what is the decimal and fraction for the amount that is shaded over here? Well, there's 5 out of 10, right? 5 tenths. What decimal does that equal? Well, that equals 0.5. And then there's another fraction that equals, that is still actually even equals 1/2, right? And you see that this is half of this rectangle. Now, if I'm looking at this to see what's shaded, this has 100 in it. Notice the small squares. There's 10 this way and 10 this way. If I multiply that, that tells me that there's 100 in here. 10 times 10. Okay, but I have 1, 2, 3, 4, 5 down and 10 across shaded. That means I have 50 shaded. Well, what's 50 100ths? Well, I have 50 over 100ths. 100. So what does that equal as a decimal? I'm sorry. Yeah, what does that equal as a decimal? Well, that equals 0.50. And yes, I had to put the 0 because I have these 2 zeros. I have to move this over 2 places, right? So what does this equal as another fraction? What's an equivalent fraction to this? Well, I can divide both of these by 50, and I end up with 1/2. These are equivalent, right? So now for 2/4, right there, what would be an equivalent decimal for 2/4? Well, again, well, I can divide that, can't I, into by 2, and I'd end up with 1/2, and that would tell me that it's going to be 0.5 because 1/2 and 0.5 are equivalent. Or I can multiply it by 25, which would give me 50 100ths, which would be this. And then I would divide them both by 10, and that would be 5 tenths or 0.5 or 0.5, right? 51, you know, it's, you know, they're equivalent. So that whatever, if you put 50 100, that's not bad. You're on the right track, because here you would have had 50 100ths, and then as an equivalent decimal you would have had 0.50, and it still equals 1/2. But you could also just you could have divided it by 2. So there were a lot of ways to do that one. Oh, I forgot number 3 up here, huh? Okay, so I already got number 3 is already 6 over 10. So what would be my decimal equivalent? Well, I'd have my decimal with 1 0 right here, 6 would be 6/10. And if I just know my place values, then if I see 6/10, I know that's what it is. Okay, but this one I'm gonna have to figure out again. Now, I can multiply this by 2 or 20. 2 is usually gonna give me where I want to go quicker, more quickly. Yeah, more quickly, not quicker. If I multiply this by 2, if I 2 times 2, I have to multiply the numerator by the same thing, times 2. That equals 10 down here and 8 up here, so that equals 8/10, which equals what as a decimal? 0.8, right? So there we go. That's all there is to it, guys. What would be, let's look at a little review real quick. What would be the first step in finding an equivalent decimal to 3/5? What do you think would be my first step? Well, my first step would be to, what can I figure out, what can I multiply this by to get it to 10 or 100? And in this case, it would be 2. So you'd have 2 times 5 and 2 times 3. Remember, whatever I do down here to the denominator, I have to do to the numerator. So what are the 2 fractions that are equivalent to 3/5? Well, you have 6/10 or 60/100, right? Because if I multiply it by 20, right, I get 6/10, 60/100. Then, so what are the decimals then? 0.6 and 0.60. Simple, right? Okay, we'll talk about this more. I'll have some work. I have a worksheet right here for you to do, so that you can try to figure it out. Now, you have right here 1/3. This is one I do want to talk to you about. You're not going to be able to get this third to 100 or 10. So what my suggestion would be is get as close as you can. So what's the closest I can get to 10 or 100 with this? Well, I could do it by 3. I could multiply by 3. And then kind of guesstimate from there. So now I have 3/9. So then I can go, I can say, well, if it was 10, it would have, so I could go with a 0.3. Or you could go to 99, which would be 33 here, 33 here. So you'd have 33/99, and you'd end up with this repeating decimal. And you could do it with, 333 or, whatever. But that would be about equivalent. It's not an exact equivalent, but it's as close as you could get, okay? It's closer than multiplying by 25. These other ones are pretty straightforward. Now, this is 0.5. So what would be this as a fraction? Now, you do want to try to get to your lowest fraction. So this is going to be 5/10. So what's that as the lowest fraction? Well, I divide them both by 5 and end up with 1/2, right? And just keep doing it like that. And if you can, like for instance, this right here, that's going to be 667. What? It's tens, hundreds, thousands, over 1,000. Okay, what did I multiply by to get that? So, but that would be your fractions, and that would be switching between decimals and fractions. So hopefully this was helpful. If not, and if it was really confusing, I'm sorry. Oh, why is an extra worksheet? Just give it a shot. Ask your questions. Write down your questions so we can get right to it on Monday. All right. All right, guys. I'll see you later. Peace.